Hi, everyone, and thanks for joining Net Zero Building. I'm Pat Flannery from Canadian Contractor Magazine, and today I have Anton Van Dyk with us from Leighton Consulting. Anton has been working in and around windows and building engineering for more years than we will reveal here. And he's got I think some great information on us on specifying, picking out how to think about your fenestration in your project, in your home building project, your renovation project, with an eye on net zero and how we're going to have to make everything more insulating, more energy efficient, and in the coming regime. As you know, this is something that it is not going to be an option. It's not going to be a market forces thing very soon. It's going to be something that we all have to look at because the building codes are moving in that direction. And Anton is, in fact, in BC, where has been at the vanguard, really, of a lot of this. The STEP code that's been picked up by the national model building codes as a at least in concept, and a lot of the provinces across the country are going to be moving to these models if they haven't already. So Anton has, I think, some very critical information for us, and with that, I'm going to turn it over to you, Anton, and a little bit about yourself, and then give us your presentation.
Perfect. Thank you very much. And this opportunity, I think it's great timing considering how the tier codes have basically gone national. So what I like to say to people is that if this isn't, oh, I don't have to worry about this. It should be, I need to prepare for this because it's inevitable. And where things are going and where codes are going, and it kind of makes sense. So when this topic came up, I was like, perfect. I actually was involved in a net zero project back in 2020. And this presentation today is probably more of I'm just going to explain my process that I went through when I had an opportunity to be involved in a net zero project. And I think just so everybody kind of gets an understanding of a bit of my background, is prior to doing what I do now, I worked in window manufacturing for over a dozen years, primarily the vinyl market, and focused on the British Columbia market in particular. So, and the reason why I bring up BC is it still has a tendency to be kind of the code leader in pushing initiatives more aggressively than any other region, probably in all of North America. It's interesting actually when you talk to like European import windows, they tend to look at the Vancouver market as the gateway into North America, because if you can meet expectations in Vancouver, you can kind of meet expectations across the entire country and into a lot of regions in the United States as well. So just some food for thought. If you're ever trying to gut test whether or not your product would make it throughout North America for these higher performance standards, Vancouver is always a good gateway to sort of check it out. So prior to getting into the window manufacturing into the industry, I spent over a dozen years in the building envelope consulting field, which is really, for those of you that don't know, the leaky condo kind of issues that Vancouver went through in the late 90s, early 2000s. And so kind of stitching the concept of fenestration and consulting, management, how to pick the right thing, how to make good decisions, what decisions impact other things, and where we go. It's kind of the logic I like to put into everything. So I'm going to share my screen here. I put together a small presentation on how to do this. Just give me 1 second here. Here we go. So, Patrick, I'm assuming you can see the screen. It's working now. So we're going to talk about fenestration in net zero buildings, basically. Pretty simple topic. What is it? What does it mean? What do you have to prepare for? All that sort of fun stuff. So, what are we going to go over today is, what are high performance window categories? It's this idea of I need a net zero window. What is that? How does it compare to other certification programs of windows? Can you use them? What is a high performance window? This is a term that lacks context, and we're going to go through an understanding of the definition of high performance because it's kind of lacking a bit of goalposts, I guess, in a lot of cases. how do the step code and the tier codes, what are they? How do they allow for, how does net zero work in these systems? And this is where I sort of get into net zero isn't, oh, I don't do that. That's for another person to focus on. I just deal with code minimum. Well, eventually, with the tier codes and the step codes, net zero will most likely become code minimum. So, there's talk about, is it 2030? Is it 2035? The reality is it's coming up. And there's jurisdictions actually in Vancouver, the Lower Mainland area here, where municipalities have adopted already the upper level of the step code, which is net zero, which is challenging because not everybody's ready for it and they don't know how to. And so these sessions, I think, are really cool because it gives you now a sort of a foundation of understanding of what do I need to start? Where do I need to go? Do I need to change my mindset and my thinking of certain things? Trade-off methods. This is the brilliant part of the step codes and the tier codes. The problem with this is everything is picked in silos. Insulation is picked in a silo. The windows picked in a silo. The heat pumps picked in a silo. Whether there's on-site generation of energy. The real value of the step and the tier codes is you can trade off your window performance with your wall insulation. You can trade off the air leakage with a heat pump, and there's certain metrics that you can play around with. And so the sophisticated analytics that can go into determining how one thing impacts another thing is, if you figure it out, can be a massive option. And I got a little story I'll tell about how by spending more on windows, it saved on insulation cost. So when we think about, oh, everything's just going to cost more, yeah, not necessarily. If you put something here comes down. It's this how the balance of everything works. And then the role of the energy advisor when it comes into making these decisions about what is most important that goes into it. But before we start, I like to, when I do presentations in front of big groups of people, I discovered there's this context exercise, and it was a guy I worked with that taught me this, and he used to use this context exercise in presentations before he would start anything. He'd ask the question, what is the best fruit? And when you have a group of like 50 people in the audience, you could get 20 answers. And when you ask people, how long would it take for you to debate which is the best fruit? You could be there for a day type of thing. Now, if you said, what fruit provides the most vitamin C? So you put context to the question. Now you can kind of narrow it down to two, maybe three different fruits, and then you can probably have a very sophisticated discussion, not an argument at this point, about what does the data say and where do you go. So I changed the question to what is a high performance window? And I started doing this out of frustration because the number one answer you would get from people was triple glazed. Well, I know from developing windows that in mild climates like Vancouver, you can, in some cases, on a double glazed window, you can get higher performance than a triple glazed window. And now if you bring the carbon conversation into it, you start asking the question, is a triple glazed window the best way to go? So it's not always sort of the key criteria there. So it's lacking some context when it comes down to it. Low U values. There's another one that pops up. Well, my question is how low? How low is low enough? Do you have to be that low? Now, this needs context because if you're in a climate that goes to -20, -30 versus a climate that really doesn't get below -5, you have a different sort of perspective on what is considered a low U value window. High or maybe low solar heat gain. This is always a fun one. I'd always get an audience member or two. One would say, a 0.45 solar heat gain because it's free heat in the winter. And then another one would say a 0.2 because it provides summer cooling effects. So depends on how you're looking at things, it might be different. So it's not always the same. An airtight window, of course, is a high performance window. How airtight? That's kind of the next question that has to come into it. And then a lot of people will throw out the terms like, well, a passive house window is a high performance window. Is an Energy Star window must be a high performance window because it's branded. So, well, we've had lots of conversations about that as well because they don't Windows certification programs don't always consider how the window performs in a specific home. And so I always put some caution out there when people are picking a window based on how a window is certified versus how a window is actually designed for the intent of the home based on its orientation, climate zone, all those sort of fun things that you need to consider when it comes to project specific designs. So What is a net zero window? What is a high performance window? Well, we do know that we have some categorized window performance. We got passive house windows. We have Energy Star windows. These are systems that certify a window. Passive House does a great job at certifying a window, but then also how that window is used in a specific building. So it comes equipped with an entire design tool that allows designers to integrate a window of a certain performance into a home, and it will factor in orientation, exposure to the sun, all those sort of fun things. So it's a good system for it. Whereas an Energy Star window is just a labeled window based on if the window is sold on a store shelf. It's like rating a washing machine, your dishwasher, your television, that type of thing. It doesn't care if the window goes in a high exposed south window in a climate zone that gets potentially up to 35 to 40 degrees Celsius in the summer. It doesn't really consider that in its decision making, so that one you have to be a bit careful. But is there a category for a net zero window? And I get this question all the time. It's like, oh, I'm building a net zero house. I need a net zero window. Do you have one? Well, what is that? There's no like logo you put on a window that says it's net zero. So the reality is, okay, then what is it? If it's not branded as something, if it's not certified as something, what is it? And the only way you can kind of dig into this is you need to know how people design net zero homes and what is it? And so, talking about what are all the things that make up a net zero home? Well, really simple. This is what I like about my previous background being in building envelope consulting, mainly dealing with leaky condos and moisture ingress. But you really develop a holistic approach when you work in that field about how one thing impacts another thing. The caulking around a window impacts how a window will perform. It impacts how the wall will perform. How you seal the window to the air barrier will have an impact on the air tightness of the window. It's not about the window, it's about the integration of the window. And that's something that I really focus on a lot is there's one thing to think about how is a product rated and how do we determine and certify a product like Energy Star or Passive House will. But I like to always go one step further and say, how is that window or door going to perform as it integrates into the building envelope of the home? And that's a whole nother level of thinking and digging in deeper. And I always used to say, there's this person that's always on every project, and we call it Nick, or his name is either Nick or Other. And when we refer to who Nick is, it's NIC Nick, spelled NIC, and that stands for not in contract. Or you have a person named Other because there'll always be a comment on contracts or drawings that says, by other or by others. And it's this idea of who's responsible for connecting the dots of all of these things to make it all come together. And within net zero, within the tier codes and the step codes, you have this person now called an energy advisor, and that's their role. Usually working with, if it's a complex project, it'll be working with an architect and a building envelope consultant. On smaller homes and projects, you might just only have an energy advisor. But the job is to look at everything in a holistic approach. And so in this case, what type of windows required in a net zero home? Well, there we go again. High performance windows, triple glazed. That must be it, right? I just got to buy triple. So to the person who doesn't understand fenestration, doesn't understand how a U value is determined, they generally will think, well, a triple glazed window is better than double because there's more glass. A double glazed window is better than single glazed because there's more glass. That was the philosophy probably in the 80s when low E coatings were not really a thing. And the only way to upgrade a window was to go from single to double to triple. And then you start looking at, aluminum frames, thermally broken aluminum frames to PVC frames to fiberglass and so on and so forth. That's how we used to talk about windows. And so we have to stop talking about windows in the category of high performance based on that sort of older thought process that goes into what is high performance. Bring the carbon conversation into this, and you start to really get some deep thinking about, should I add that extra layer of glass? Is there a better way to do it? What's the consequence of it? So net zero, at the end of the day, is a system. It's not about individual components that are selected based on their individual performance making up the system. It's about how a component influences the other component to create this overall outcome of performance that goes into a home. And what's cool about net zero and why I actually really like net zero is it starts to factor in things like angle of the sun, orientation of the home. You start looking at it going, the windows on one elevation might have a different performance rating than the windows on another elevation, just based on exposure. And it's a standard and a system that makes you think. It's not just like there's a spec sheet with the list of items on it, and you check the box and you supply them all and we're all done. Now, you could probably do that, but it will literally result in you picking the higher performance option of everything across the table, which that's where the complaints come from about why does this cost so much. Then the reality is if you can learn how your product influences another trade's product, and this is the skill set that I strongly recommend builders start to develop, is if you know how window performance influences how much insulation goes on a wall, or if you know how much the window to wall ratio can impact how much insulation or what U value you put in a window. Those things can start to play a role in saving money on a project because now you're not going to be kind of just putting in top dollar into everything at the end of the day. So with that in mind, so if we know what a net zero home is, we know what a net zero system is, then we kind of get into this question of, okay, there's no certification program for a net zero window. So now I need a good window. I need a window that's going to work well in a home. Now, if a house has 3 windows, you probably don't need that great of a window. But if a house has 50 windows and there's a lot of them, it's going to change what you do and it's going to change your mindset. And so the story I like to tell on here is a builder that I knew. This is in the early days of the BC step code. I think step 1 was the minimum, maybe step 2, but there was a jurisdiction just outside of Whistler that I think was pushing higher tiers, layers of the step code early and moving to like a step 3 early. And what happens with the step codes and the tier codes is it gives municipalities an opportunity to say, hey, we want our buildings built in our municipality to be better and now because they're going to be around for 50 years. So let's enact this soon. And the consequence of that is, are all the builders ready? So some municipalities jumped to step 5 right away, and builders just said, I'm not ready for that. I can't do it. I'm not qualified. I'm afraid to even try because what if my outcome doesn't work? So I'm going to start with step 1, step 2, and I'm going to get good at it, and I'm going to move my way through it and go from there. And so I get a call from a builder who's building in a step 3, tier 3 kind of region, and he's stuck with using triple glazed windows all the time. And he calls me up. He goes, why do I always have to use triple glazed windows in step 3? And I said, you don't. My experience is a U value of 1.4 works very, very well in a step 3 building, just based on what I'm being asked to supply by my clients currently operating in that. And I said, why are you using a 1.0 is what he was told to use. And I'm like, what are you putting in your wall? My first question was, what are you doing with your walls? And he goes, well, we're framing with 2x8 studs because we need more insulation. And I'm like, you do 2x8 studs? I go,
Jesus.
why don't you do the classic wall assembly on a step 3 building would be a 2x6 stud with bad insulation with 2 inches of exterior rigid insulation, that type of thing. And he goes, oh, no, we don't want to do the exterior insulation and the continuous because we don't know how. Like, okay, that's not hard to learn. Number one, you can probably actually go to school and take a program on that now. And so they stuck with what they knew, building with a standard stud. Instead of going 2x6, they went to 2x8. And I said, what's the window to wall ratio? And he goes, he's kind of like, well, what do you mean? And we do get down to it going, yeah, it's about 30, 35. It was up there. It was quite high. And I said, take 6 inches off the window on both sides and see what happens. And so he made the windows a little bit smaller, which means it adds wall insulation. And sure enough, it started to change the calculation where the U value requirement of the windows started to drop and the expectations, because he basically had more opaque wall area that had a better R value. And so just an example of how you can sort of play the game a little bit with sort of ideas. So now if you don't have a net zero window, what the question really comes down to, or not a net zero window, but a high performance window, are there certain features that you're looking at that can determine whether or not the product has the capability of being a higher performance window? And back in I think it was 2015, it's quite a while ago now, almost 10 years ago when time flies. But the North American Passive House conference was held in Vancouver, and at that program they put on a 2-day event on windows and just for the window industry to come in and learn about passive house windows, what it takes. And they gave this presentation to everybody, and to this day I've kept it and thought, the question that really comes down to is, do you want to develop a passive house window? That's option A. Or, and how big is that market for supply and does it make sense to do so? But what about, my question actually became, what does it take to achieve a passive house rating of a window? And so there's these sort of tricks that come out of this presentation in order to develop a passive house window, and things as simple as, a short fat frame versus a tall skinny frame. Well, this increases your glass to frame ratio, which starts to boost the performance. So just ideas of slimming a frame down is kind of one initial step you could take to kind of recognize, now if this is and it's just not quite hitting the number you want, start to think about making the frame lower. Now, what comes with a lower frame? Harder to meet water penetration resistance because you're sucking water up vertically. And the taller the frame, the better. So there's this now compromise you have to make between water tightness and thermal performance potentially. Now, you can make a small, slim frame work quite well, but in regions like Vancouver, where they're very susceptible to wind-driven rain and those types of focuses, that's where you get into the debate with some people. Is some people say, well, a window with a water rating of 720 pascals, that's high performance, but then maybe the U value is not as good. So then what is high performance? So that's kind of the first thing you want to look at. Minimizing the effect of reinforcing. Another big battle I think the industry always faces is some of these net zero homes. These windows are like 12 feet wide by 6 feet, 7, sometimes 8 feet tall. They're huge. And everybody wants lots of glass, big windows, long spans with mullions, all those things. And as you start filling up a frame with steel, what happens, right? If you're starting to do project-specific thermal modeling and you're bringing in the mullions with steel reinforcing, you're trying to hit the deflection limit of L over 175, what do you do? And so playing around with, you can see situations here where all the steel is inboard of this insulation, right? If you think of wall systems, we're putting on continuous insulation on the outside. Why? Because the studs are thermally bridged. Now, I could put bigger steel in this chamber because it's bigger, but now it's going to be exposed directly to the outside. By putting a smaller piece in here with insulation in front of it, what are you doing? You're warming the steel up. You're reducing the conductivity. It's little tricks like this that go, now it's smaller steel, so maybe it's not going to be as strong. So there's a compromise there, right? This is using some inserts that are composite materials for reinforcing. This one, you can see they angle the steel to align with the isotherms. Like, brilliant concept. Performance tuning. This is one where I love this process because, when you start learning that long, skinny vertical chambers are really good for reducing conductivity, and anytime you have a horizontal chamber, it's really good to stuff it full of something. You can see here the glazing pocket, breaking this up with some sort of seal so it creates two chambers. Long horizontal chambers conduct energy quite efficiently. So you want to kind of put a stop to that. Middle gaskets in the operables are always a good benefit for stopping horizontal chambers. But it's this idea of tuning a window, because it's this, if you can change 5 things on a window that affect the metric U value by 0.02 to 3, and you can do that 5 times, before you know it, you've reduced your thermal performance by a whole factor of a tenth of a decimal point. So just really cool tricks. And there's a process I call thermal R&D, where before you go to certify your product, run it through Therm, look at it and go, well, what if I fill up every cavity with insulation? These little dark lines here would be insulation cavities. That's going to cost more. What U value do I get? And then start removing insulation, because it's going to reduce your cost, and evaluate the impact of removing insulation from certain locations on its U value. And why do you put 2 here and 1 here? Well, it's been optimized. They probably figured out that filling it right up didn't necessarily get them the target that they wanted to for the cost associated with it. So you're constantly fighting this battle of performance and cost. And then there's playing around with all the wonderful low E stuff that you can put into a window system. This is data right off of Cardinal. You've got your single coat, double coat, triple coat low E's. Now in a triple glazed window, you've got a whole bunch of surfaces to play around with. And this is why, there are poor triples, because a triple with one low E versus a triple with two low E versus a triple with three low E, you start trading off visual light with performance and trying to determine what is the best combination of low E coatings with certain spacer bar material that then make up how well your window frames perform. So, if you're in the window business and you're wondering what you need to do for net zero, just start focusing on the little things you can do to make a window better. And then we'll start talking about the goals that you want to hit here in a second as we go. So why are we focusing on this? What is it about net zero? Do I need to be ready for it? What's the inevitability of it? Well, in Canada, we have the tier code now under the 2020 National Code. British Columbia has had what we call energy step code now for 5 years, maybe. And what they all do is they start with step one, tier one, and generally it's minimum code. There's zero requirement for improvement. This is the national one. And all step one really does is it introduces the process of evaluating buildings for thermal performance. It doesn't say you have to necessarily hit a target that is overly over the top or difficult to do. So a good example is air tightness. It requires you to do blower door testing, but it requires you to list the result of the blower door test. You don't have to in particularly hit a number that will prevent you from or will give you occupancy of the home. Step two and above, now you have to start hitting some performance targets because, it's 10% more efficient. In British Columbia, under the 2024 BC Building Code, we are at step three as the minimum level required for single family homes. And to be honest, a lot of municipalities adopted upper levels of this when this first came out. And most people have 100% comfort level of a step three building. They know what it is. They know what the building materials are. They've optimized things really well. A lot of trial and error goes into it. And that, I think, is the brilliance of this system, is it lets you try and then fail and then try again and then win. And, I get really concerned when I see there is just one municipality here outside of Vancouver that just has adopted this. They just announced it on the news last week. They're jumping right to step five. And it's like, does that give you the opportunity to try and fail as the builder and learn as you go? So it's just sometimes you got to be cautious how aggressive you want to move with things because failing too quickly and too hard can be problematic. So the tier code nationally, you can see it looks identical to the BC step code in its targets, 20%, 40%, and then basically we're net zero ready at the step five, tier five kind of category as we go. So net zero becomes a path, a method for high performance. Passive house would be an option you could probably do. I'm sure there's an Energy Star option. These are kind of branded techniques and systems that you can use to hit the upper level of the step code and the tier codes. So, you might be thinking, do I need to worry about this? It's coming. It will be here. And the idea of net zero ready is basically the term ready means that the home has to be built in a way that when renewable energy can be produced, whether it's on site or nearby, that it has the ability to take on that concept. And this is why you're starting to see some jurisdictions when they're in this category say no natural gas in the home, because they're designing the home with the assumption that there's going to be renewable electricity delivered to the home, whether that's solar panels on the roof, any other type of generation that goes into it. So the cool part about it is you're really designing a home that's high performance before it's even ready to receive the renewable energy that would make it even better at the end of the day. So yeah, the core philosophy that I always like to look at when it comes to, what is a net zero home, what you value as best for a net zero home, is that a lot of these standards push the agenda that it's about putting the analogy I like to use is put a sweater on before you turn the heat up. And so when you're working with an energy advisor on whether it's a step three building, whether it's a net zero building, what you'll notice is there's this emphasis on the envelope. And it makes sense, right? As a kid growing up, your parents taught you, how to save money in the household was you don't turn the heat on until you're ready to turn the heat on. So explore every option first, right? I grew up in, my dad grew up in Hamilton, and they actually just traveled back there and went and visited the house he grew up in. Five brothers in one room in the upstairs attic. The basement, was an old coal-fired, where the coal truck would come and dump coal into the cellar. And that's how they heated their house. And so, we live in a society where you don't see natural gas, you don't see your energy. But when you see a pile of coal delivered to your house and you see houses that had these things, it's a very different mindset you had. So back in the day, the heat wasn't turned on until you explored every option. Put a sweater on, wear a blanket. There's probably a wood burning fireplace in the house. So that logic of putting a sweater on is the same logic of let's make the walls thicker, let's make them more insulated, let's make the windows better, let's make it more airtight. And so you'll see here there's this trend towards envelope first, and which I really like because that's my background is building science and envelopes. And there's potential consequence to that because when you make something more insulated in the summertime, what's the consequence? Well, that heat that's generated inside just by operating, people living in the house doesn't leave as efficiently. So now your cooling loads will increase, and that has to be factored in when you come down to certain things. So the energy advisor becomes the decision maker who determines what does what. And the way the process works, this is a sample of an energy compliance report. This is the township of Langley. This is where I'm coming from today, where I live. And this was just available online as an example of a template of what a compliance report would look like. This one, just sort of zoom in here a little bit, it says step 3. So that's the proposed step. And you can see here, it starts to say windows, doors, and skylights. It gives you a window to wall ratio of 17%, and it specifies that a U value of 1.4 and a solar heat gain of 0.23 is going to be required for the fenestration on this building. And, you could take it for what it is. And each item here they're designed in partnership. So the window performance is linked to other aspects of the building. But from an average person looking at this, you're almost going to look at this list as a checklist. I need to put this much insulation in the wall. I need this type of windows. I need to do this to my roof. And you could just follow it along if you wanted to, accept it for what it is. Or you can sort of dig a little bit deeper into this and go, well, what if I do something? What if I change one thing on here? What happens to something else? And so my personal experience going through this process was interesting. So this is a bit of a case study. In Vancouver, we have this thing called the P&E, which is this summer fair at Playland. And every year they do this prize home lottery where they give away a house as a lottery system over the summer. Everybody buys tickets. And so 2020, this is a modular constructed building. So they assemble it on site at the fair, and then they would dismantle it and set it up on a house in a location somewhere throughout British Columbia. And it's net zero. Or net zero ready. And so they asked for windows, and we're like, sure, no problem. What was the window they asked for? Well, of course, triple glazed. They wanted a U value of 1.0 or lower, which was great. We had a window with a U value of 0.97 based on a certain low E makeup that went into a frame. A solar heat gain coefficient. Now, here is the kicker, is they wanted a higher solar heat gain coefficient, but there's a problem with that because by specifying the U value, a lot of people think the solar heat gain can be defined independently from the U value. They don't realize that they're totally linked together. And so energy advisors need to be well aware that, go back here, when you design like a 1.4 and 0.23, well, what'll happen is you'll end up selecting the window based on U value because it's kind of codified. Tends to be more important. We're in a bit of a typically colder climate zone. But you can't just dial this into exactly the number that they want. And they need to be informed of that and understand that more. You get what you get based on this. Now you can adjust it. Like I could probably upgrade the low E to, let's say I upgraded the low E to a high solar gain low E. This number might go from a 0.97 to a 1.1. And the solar heat gain might go from a 0.22 to a 0.4. Right. So that's sort of the impact that you could kind of have. And so it really becomes a good conversation to have with the energy advisors and the design team to figure out what that is. And in this case, this one was a simple low E combination of Cardinal 270 and 180. Air leakage was A3. I found it surprising that people weren't digging into the actual performance of the air leakage, just that A3 was, from a NAF's perspective, was sufficient. And an A3 rated window for air leakage is 0.5 liters per meter squared per second. And now most windows in this category, their outcome is significantly lower than that. They could be something like 0.05. So sometimes it's good to look at what the actual data is for air leakage, because air leakage in high performance buildings become a really, really important target to hit. And when buildings fail to meet the expectation of air leakage, everybody loves to point the finger at the windows. So design intent towards air leakage, and the better you can get, is strongly recommended. So we get a trade-off method here, basically, where the insulation, so, net zero, like the whole home performance, right? So we talk about, let's just look at windows and walls in combination, right? So you have, if you put code minimum windows in a building, you would need lots of wall insulation in order to hit net zero. And I mean lots. So that's probably not a good economical way to go. Your wall might be 2 feet thick. A good window, it's just better than code. What's that, a 1.4 maybe window? Yeah, you're going to need less insulation. That's kind of your typical step 3 building. So not quite net zero, but you're going to need still more insulation than code minimum. Better window, even less. And then I go great window, but not a passive house window, needs even less insulation. And so it's this idea that if you increase your window performance, this number will come down. Pretty simple. How much it comes down and how much money a builder might save by putting in a better window might get interesting. And an example I use is a project that was already going triple glazing. They wanted a U value of 1.2, and I offered an upgrade in low E that brought the window below 1.0, and it removed about $3,000 worth of additional insulation on the project. So there's a little cost increase for the windows for the added low E, but the net cost was a savings overall on the entire home. And this is the idea about being whole home performance. Same with window to wall ratio. This is 17.1%, which is quite low. So you tend to not need, you have more wall area per window area. So therefore, your home is already quite good and efficient. We're seeing homes that get up to 35%. And that's where you start to see the drive for high performance windows and thicker walls, because you're trying to make up for the difference that goes into it. So pay attention to these few numbers in here when you see these compliance reports. And, if you're trying to develop a window that would go into net zero, for example, look at what the energy advisors are specifying. Look at what designers are doing, because it'll give you an idea of what to expect. So just wrapping up here, this is a net zero window. It's no picture. It's a bunch of words. It's a window that meets the designer's expectations based on their whole home design. So there's really nothing out there that will say this branded category is net zero. It is a window that is high performance within the boundaries and the balancing of the entire home. A window that uses, that has a U value. This is the cool part. A window that has a U value in accordance with NFRC or CSA A440.2. Why is that important? Well, my perspective is on this is I don't have to go anywhere. I don't have to go to another party. I don't have to go to another organization, another association. All of my product is either certified for NFRC from North America or in Canada. It comes with a U value. I've already worked with a lab. I've already done all the stuff. I don't need to do anything else. That's it. Maybe I have to develop a better window, but I don't have to go to Europe to get them to certify a product. I don't have to go to another association and pay a fee to list the product. I don't have to label it a certain way. It fits right into my standard operating procedures in my production facility for labeling and what I do. And that's the beauty of this program, and why I generally recommend it over others, because there's just way more access to product if you're in net zero. Higher than average U values, I like to say 1.0 metric and lower is commonly what I would see in a net zero home, but that's also dependent on the window to wall ratio, depends on your amount of insulation, many other factors. So don't take this as gospel. It's just an idea of what it could be. Now, the other cool part is it will balance cooling loads with free winter heat. So this idea that high heat gain is always a good thing to cut down on heating loads, You got to factor in cooling loads. So net zero, it will make a designer focus on the impact that the summer time is going to have. So you will see less and less push for high solar heat gain windows in this category, because the impact that that will have on cooling loads will make it harder for the home to hit the overall calculation that you need. So there's going to be a true balance between the two. And I suspect in the early days of this, a real challenge will come from understanding how U value and solar heat gain, how those numbers work within a window, and how you can't just specify them as independent numbers. And then air tightness, like I said earlier, be very careful about air tightness, because it tends to be the first thing that's blamed when a whole home fails a blower door test. And there's linkages between the two, but there's also not. And so for windows and doors, we reference air leakage as liters per second per meter squared, but air leakage for a whole home is in volume, so meters cubed. So there isn't a direct linkage between the two. But if you want to take yourself out of the equation of being vulnerable to the outcome of a blower door test, my recommendation is to always have products significantly lower than 0.5. And when I mean lower, I mean like a 0.07, 0.05, that type of area. It's not difficult to achieve that in like a triple weather stripped product that's like casement awning using multi-point hardware, that type of thing. So folks, and usually that type of window with good bulb seals and good air tightness is usually a window that has a good U value already, because you have minimized chambers that go into it. So yeah, so that's kind of the idea of a net zero window and door in a net zero project. And yeah, we'll go from there. So I guess, Pat, if we want to discuss some questions, do you want me to stop sharing here?
You don't have to unless you want to go back to a slide, but it's either way. That's awesome. Anton, thanks for that. Great basis for everybody, I think, to start thinking about well, just thinking in the right direction about what you need to know when you're picking out your fenestration. I think one of the key things, one of the key points, at least that I was taking out of that, is for a very, very long time in this country, and I think in the early days, the idea of solar heat gain was basically the more the better. That was just because everyone's thinking cold climate. I believe the entire Energy Star program was developed kind of in reaction and in tandem with the Americans. And so the feeling was always, well, we have to maximize solar heat gain here in freezing cold Canada. And back in those days, no one had air conditioning. And I didn't. And I don't think I lived in a house with air conditioning until the late 80s. And that has changed. Like, look, would it almost be accurate to say, Anton, that these days you actually want minimal solar heat gain with maximum insulating value if you can get it, right? Because you've got those air conditioning loads in the summer are going to impact your overall energy usage, possibly more than your heat.
Yeah, there's a lot of debate, and I can't answer like from an energy advisor's perspective. I remember being at a conference and somebody asked an energy advisor who was speaking on this topic about what's more efficient, cooling loads or heating loads, and he said cooling loads. So he was actually saying it's
Oh,
better to have high solar heat gain windows for free heat in the winter to
okay.
reduce your heating load, and then to cool the house down in the summer. And I went, that's interesting. Now, there's also some debate about how long the cooling load is. I've seen some people say, like in BC, especially like the Vancouver area, we only have 2 months of cooling load. And I was like, well, no. I know people who have air conditioning and it kicks on in May and it doesn't turn off until September.
Absolutely.
So I don't know where you're getting that 2 months of cooling load is, because maybe that's skewing the calculation. But what we're actually seeing more and more is what these step codes and tier codes are doing is they're moving you away from product certification. That for rating, like a lot of these product certification programs were designed so that when you're shopping in a store and you're comparing one product from the next that's on the store shelf, one's more expensive, one's cheaper. You can look at a label, an energy label, and say, well, this product is rated higher than this product. It's like when you buy a car, the sticker in the window of the car, what's the biggest number on that sticker? It's like this big. It's the fuel
Yeah.
mileage.
The gas
The car
mileage.
industry figured this out, that they can get probably another 5 grand on the car if the fuel mileage is below a certain rating.
Right.
That's how people make decisions on buying a car. Now, if they actually provide a detail on that saying, if you buy this car and you have a lead foot, you won't get that number, by the way.
Yeah, yeah, yeah.
So
Your mileage may
what these
vary.
product certification things do is they don't advise you how the product will work on the home.
Yeah,
And that's the biggest mistake that everybody makes is they go, "Oh, I bought Energy Star windows. My house should be high performance."
yeah,
No,
yeah.
because and energy, I even remember a notice that came out many years ago. I think it was through Enercan, through the Energy Star program, and it said it acknowledged this. It said our system is designed to rate a product, not how the product performs in the home. And you'll spot right away when a designer designs the same performance in the window on all four elevations of a house, you know you missed something
Yeah, yeah,
because your performance is all different. So everything from the NAV standard to Energy Star to thermal, all of these programs are designed to provide a product rating. They're not designed to tell you how the product will perform and make the house feel. And I've never, my entire career, you talk about time, so I'll go back 25 years, is when I first learned about the Energy Star program from a Vancouver perspective. Well, what do we have in the winter in Vancouver?
rain
Clouds. We
and
have we
clouds.
have
Yeah,
no sun.
yeah, yeah.
Like we're like one sunny day and everyone's like sitting on a patio in Vancouver in the wintertime. You go to, I guess, Winnipeg and you have a lot of winter sun, right? So it's kind of a tough thing to say that these certification programs that can represent a product across the coast to coast, it's not realistic. And so that's the brilliance of net zero is that it forces you to think about holistically about the whole house
Yeah.
and to spend time on that. And I think the challenge most will have is they think, oh, I have to hire this energy advisor who's going to do this compliance report and give me a checklist, and I'm just going to go do it. Perfectly acceptable thing you can do, and you'll hit the targets and you'll win. You'll spend more money that way. The
Yeah.
actual thing you want to do is, and this is a recommendation I have, is don't hire an energy advisor for a one and done assessment. Hire them for the initial assessment, get the numbers, gives you the checklist. Go get everything tendered. Go get all your sub trades, all your suppliers, but like ask your window manufacturer to provide two, maybe three different quotes of different performance values. So you know the number. Give me a quote for a product that's higher in U value and a product that's lower in U value. I want to see the difference. Then as a contractor, what I would do is sit down with my energy advisor and I would say, remodel this based on a window that is lower performance and remodel it based on a window that's even higher performance and tell me how it adjusts the amount of insulation in the wall.
Mhm.
Because then it goes, oh, it'll reduce your insulation in the wall R value by X. Then you go to your insulation contractor and you say, okay, now how much would I get for a credit if I reduce my insulation? And that's the game to sort of play within the step codes to fine tune the outcome at the end of the day. So
That's great advice. That's useful. I think that everybody can take away. Um, big windows. You and I mean, I've been doing the window industry longer than I've been doing this building side. And this is the trend everyone comments on is it just seems like every year people want larger windows with less obstructions and thinner frames and more glass and more view, which is great. It's a beautiful look. And everyone listening to this knows that if there's one thing they can't do is they can't go against the will of the homeowner as far as what they want it to look like when it's done. So the big windows aren't going anywhere. But I mean, are you killing yourself on your net zero with a larger format window? I mean, is that span of glass really the problem? Because if I'm not mistaken, the actual problem is more around the frame.
well, the best part of a window is the center of glass, right?
Right.
Like the highest point. So more glass to frame ratio will give you a better U value all day long, right? There's no
Yep.
debating that. And that's why like NFRC gives you standard sizes so people can shop one manufacturer to the next. When you get into project specific thermal calculations, as soon as you see a window that's 8 feet by 8 feet and you just got a perimeter frame around it, yeah, like you're going to get a significantly better U value out of that specific evaluation of the window. The mistake that's made though is that bigger windows mean less walls, means less wall insulation. So if you're doing a wall with R22 and you're putting in a window with a U value of, I'll turn it into R value, like an R7, maybe an R8, like that's the highest you're really getting out of a window. So if you do your window to wall ratio, you just have more R8 area than you have R22 area.
Right.
So
Okay.
it's not about like, sure, you're using awesome windows, the best windows you could ever buy. But if the balance of windows to wall area just doesn't get you there, then good luck, right?
Yeah.
And I think that like those are numbers on paper. And I think this is something that I think people get hung up on is, well, the math makes sense, so therefore it should be good. And I want big windows because I want my view. Okay, great. I want my windows to go right down to my floor. And I always said to people, like that one story I told about the guy, like just take 6 inches off the width and the height of a window.
Yeah.
Because what do people, when you look out a window, what part of the window do you look out of? The
Yeah.
middle,
The
right?
middle. Yeah. Yeah. Yeah.
So if architecturally, if you plan windows and you put them in the line of sight in a wall where people sitting on a couch or a kitchen table, how do they look out the window? Does it matter if the window's a foot bigger on either side?
Right.
Yes, it lets in more daylight. You probably already have a lot of daylight coming in. And so it's this idea of big windows tends to be more impactful on architectural from the street curb versus impact it has on the people inside the home. Because you look through a window, you look through the middle of a window versus where it is. Um, but have you ever walked in a greenhouse?
Yeah. Yeah.
So hot.
Yeah. Very
Okay,
hot.
so more windows mean more greenhouse effect, like bottom line. So the more windows you have, the more heat gain you're going to have, the more challenges you're going to have in the summer and so on and so forth. So if you bring it into the context of comfort, big windows and comfort start to create things. Now, here's where design gets really cool and where I really recommend, working with designers that understand this is many years ago, I was involved in a project in Whistler where there was massive patio doors on this one elevation that was facing south. And they're like, I think it was like 12, 15 feet wide by 8 feet tall, massive multi-sliding patio doors, optimized all the glass. And it went triple glazed, but with no low E. This is kind of before a lot of this conversation. This is probably 12 years ago, a long time ago. I think it was kind of pushing when the Olympics were coming in, so maybe even longer. Um, but the system had like an 8 foot overhang. It was onto a patio deck.
Okay.
So what happened was in the wintertime, the sun's nice and low. You get all this energy coming in and warming things up, free heat. And then in the summertime, not a single ounce of the sun touched the glass.
Oh, nice.
So So the idea here of like individual focusing on product, like yes, you can do high heat gain windows all day long. And so it was a triple glazed window with no low E to optimize the solar heat gain. So the U value wasn't as good, but it had really high solar heat gain, but it didn't cause an overheating effect because of the shading mechanism added onto the home. So fenestration, this is one that most people miss on, is fenestration can be linked to just how exposed the window is to the sun. And can you design something that goes into it that's more efficient, like an overhang or shading? So there's just now the overhang over this had a dual benefit because it covered the deck. They could use the deck in the wintertime. There's a hot tub on the deck. So you can think of all these overhangs are too expensive, but the overhang had a dual purpose. And economically for the whole home, it made perfect sense. So those are just examples of the diversity you can put into a system like this.
And that's a comment we've been hearing for many years in the window industry is the Europeans are a lot more accepting of awnings and shutters and blinds and things like that. It's not so much the blinds; it's on the exterior. They don't mind the
Yeah.
look on the exterior of the building, and so they achieve some good things with shading, which then again in your building design. You know, Think about that. I mean, would the homeowner accept some form of shading? Would they accept some form of overhang, something recessed a bit that gives you that benefit and enables you to spend a little less, on the windows maybe because they're protected that way. And the orientation is another thing. I remember I saw a presentation a while ago. The wind load on the window, huge impact. I mean, exposure to blowing wind just changes the dynamic entirely. So, I mean, it's hard to predict, obviously, but you can predict it if you have a north-facing window. Well, what you're going to get on there, and it really changes that performance aspect, right? I liked your story about 2x8 studs. The guy trying to build a three with two. The guy's basically putting deck boards in it.
Yeah. Yeah, it's change is hard, right? And I
Yeah.
think it's good to step back a bit and kind of understand, the other part I think about net zero too is it's effective in when you bring in the right trades and the right people that know everything that you're
Mm.
doing. You can't expect one person to know how to do it well.
Yeah.
It's really difficult, right?
Yeah.
And so you have to figure out where the trades are in your system, whether it's walls, windows, and who's making the best decision and giving good advice, right? So, I worked with a guy who in the window business, and he just retired a few years ago, but he used to say it all the time, like, what type of window person do you want? The one that's going to help you pick the right product for the right home, or the one that's just going to quote it like based on how an architect spec'd it? Because like, let's face it, the people that are specifying windows, I hate to say this, but they don't know enough about windows to be able to specify a window. And a lot of it, when you see how windows are specified, you kind of go, it feels very the year 2000, the way this spec is written.
Yeah.
And if you think about it, it's only 24 years ago. But like, how much have we evolved? Like, our standards have changed in that period of time, 20 years. Yet we kind of still see things in its silos. We don't really look at the integration and for those that are worried about the tier code going nationally, what that means is it is going to put a lot of thought into how materials are selected and their impact they're going to have on other materials. In a roundabout way, it's an empathetic way to design a building.
Yeah.
You're bringing empathy into building materials because it's like, yeah, consider how you are going to impact somebody else, and that's what it boils down to. And developing the best of the best of the best of things, it gets very expensive. Like, I've seen things like carbon fiber windows, and you're like, okay, sure, great, you got the best window. But is it needed? Like, can you put in a 1.2 U value window into a net zero home? My bet is you can, with the right window to wall ratio and the right thickness of walls.
Sure.
Now, does that allow you to use double glazed instead of triple in some areas using Surface 4 low E? Yeah. Now,
Yeah.
what happens when you stay in a double glazed category? Well, your windows are lighter, you use less carbon. So now
Yeah.
your EPD conversation comes into this whole thing,
That
and
was
away you
that was
start
where I
going.
was going.
Like
That was where I was going next.
like a double glazed window in Vancouver versus needing a triple glazed window in Winnipeg. Like, we have to look at that sort of perspective and not just look at net zero as it's going to be this national thing and it's the same across the board. So because the mild climates versus cold climates, right?
Yeah. And the NRCan has already warned that they're looking at embodied carbon coming into the building code. I know Vancouver is already requiring at least statements, EPDs, environmental
Yeah.
product declarations about it. Just give me a bit, Anton, on what the tension is there and how that is and how that could potentially alter things down the road with all of these. And you've touched on it. I mean, it may end up that a double glazed window has a lower overall carbon compact than a triple glazed window because there isn't enough energy savings in there. So give me some examples of that.
Yeah, I used to do a presentation where I do this context exercise about what's a high performance window. And after everybody rattled everything off, I would show a triple glazed window with no low E in an aluminum frame.
Yeah.
And it would make people think about, like, okay, it's not, and it's, to me, it's about a missed opportunity.
Mm.
And because, when you go from double to triple glazing and I see only one low E coating, like, no one should be modeling a triple glazed window with a low E coating on surface 2 or 5 only. You should be doing a triple glazed window with a low E coating on surface 2 and 5,
Hmm.
because you have all these surfaces now to optimize. The cost of adding a low E coating, or the carbon impact of adding a low E coating, is really, really small. The carbon impact of adding a third layer of glass is high. So if you're going to add that third layer of glass and take that carbon hit, optimize it. Like, make it work for the value that you're putting into it. Number one, you're paying for that glass. Number two, it's got the higher carbon. And so, when it comes down to the embodied carbon conversation, I think the worry people have is you now have an independent system that's going to be making a decision on whether or not your product is deemed good or bad. Because what no one's saying yet about EPDs and carbon is, what is bad? What is a high number? What is a low number? What is a
Right.
good number? Right now, they're just saying, give me a report. And we've been working just recently on this in the commercial side. So we're just starting to offer EPDs now and figuring out how the calculation's done for the commercial sector, which is kind of dominating it more with the aluminum systems. But it's kind of giving the power to an independent person who says, oh, your product consumes too much carbon. So we haven't really established yet what is too much. And because then there's this other question about carbon, operational carbon versus embodied carbon that goes into the product, right? So now you could argue that what is good or bad for carbon is based on the power supply resource in the jurisdiction that you're supplying the product into. So if you're burning coal to generate electricity, now that's operational, like so on.
Yeah.
It just becomes this really complex thing. And I think the worry some people have is I've already seen people go like, well, there's too much carbon in that material. We need to use something else. And they've just completely disqualified a certain category of product that could be perfectly fine if it was traded off. And this is where you get, I think, the way I talk about trade-offs with energy in a roundabout way, you could have the trade-offs in carbon as well, where you might put a more high intense carbon material in something to have less of something else.
Yeah.
But the overall carbon aspect is lower. So I believe the way, I haven't studied this a lot, but I believe the way carbon is managed in Vancouver under the Vancouver building bylaw, it's about whole building carbon use,
Yeah.
not about individual component carbon use. So it's very similar to what we just talked about on the energy side. So the question always comes down to is how is my carbon use in my product going to impact the whole building's carbon use? Now, a high carbon material in a region that uses hydroelectricity for power generation, that's going to be very different than a low carbon material in a region that uses carbon electricity. Like, so it's, I don't think we quite know yet what it is. And that's what worries me sometimes when people are so definitive that they seem to have all the answers. It's like, I don't think we have all the answers to this yet. And that's the part that worries me a bit when it comes down to it. So,
Well, we don't, and to your point, it's going to be regional. I mean, you know, as I sit here in Ontario, absolutely every drop of power I get comes from either a nuclear power plant or a hydro dam or a windmill,
yeah,
so theoretically, I should have single pane windows throughout my house, a heat pump for power, and just crank it up, and that would be probably the minimum carbon impact that I could possibly have. So which how back to the 60s is that with your single pane bay window on your
yeah,
storefront, right? And then it just
yep,
get the heater going underneath it so you're not too cold, right? So that's that.
yep.
This is the strange new world we might be entering, but the embodied carbon standards, well, we don't know if they're going to happen, and there's some distance off. I think they're going to happen, but there's some distance off yet. But at any rate, we've got a good
The
look at it.
value I see in it, I did what was the diet? The keto diet at one time, and I got
Yeah.
this app where you literally track everything you put inside you with this app, and it's actually cool. You can scan the barcodes with it, and it'll tell you how
Oh,
much um, uh, what's the keto like
carbohydrates.
carbohydrates.
Yeah.
Yeah, how many carbs are in? And I was losing 2.5 pounds. No, it was what was I losing? It was like 2 pounds every 3 days
Whoa.
just by tracking every meal that I ate. And it's this idea that the brilliance is in the micro. We tend to talk about the macro too much, right? We think about, oh, we need to do this because of climate change, this big picture thing that we need to solve, and this big problem we need to solve. But the actual brilliance is in tracking the microscopic things that we do.
Mm.
So the first step to this, and this it sort of applies the same thing to net zero, the more we track the individual micro improvements of everything that we put into it, and we know what the numbers, but more importantly, we know what the number means. We
Yeah.
then, at the end of the day, we step back a year or two later and go, wow, look at how efficient we are.
Yeah.
Right. Someone taught me this a long time ago for goal setting. You set a goal and then you don't just set the goal and think, oh, I'm going to hit the goal or how do I, you set a goal and you write down all the things you're going to do to meet the goal. And then you take the goal and you throw the goal away and you just do the things you wrote down.
Yeah.
And to me, net zero, EPDs, all the environmental stuff, if we actually focus on how to make individual components a little bit better, right, every day,
Hmm.
the outcome, the net outcome is going to be phenomenal without even really trying,
Yeah.
right? So if we assign accountability and responsibility to every trade, to every supplier, and the contractors can coordinate this with the use of energy advisors and all the other professionals that come into it, in reality, you create something with by mistake in a roundabout way. You have some so by reducing a little bit of carbon in everything, it's like kind of reducing your carbohydrate intake in everything.
Yeah.
And I can assure you, 6 months down the road, you're going to go, "Wow, this was amazing." So
Yeah.
it works.
And I
So
think that's where they're going. To your point, that does seem to be the government approach. Um, we've seen it on the operational side, and it's starting on the embodied side. Is the idea of do a reporting program first to gather a whole bunch of data for a few years, and then
yeah,
try to arrive at some sort of evaluation of what is good, what is good and what is bad, and what's exceeding or coming in underneath standards. So
yeah.
I
I
think
think that the linkage that's tough on this is where you see the move away from natural gas. Like they're just building houses now without natural gas going to them,
yeah,
basically looking at electricity for everything. And the challenge that I think that'll be had is as we reduce our usage of natural gas in homes, we're increasing our usage of electricity. But not only that, it's not an apples for apples swap because we're switching to electricity, but we're putting a car charger in, we're putting a heat pump in, we're putting air conditioning in. Like we're putting in all these extra things that are going to, houses are going to consume more energy by default, but
yeah,
we want them to consume less. But the actual usage, so what's going to happen politically is it's the optics of this is going to look like it backfired.
right,
Homes are going to use more electricity than ever,
yeah,
but they're going to be more efficient.
yeah,
So if the metric of efficiency is how much energy a home uses, that's the wrong metric because we're increasing. Like I just put a car charger in my house. I had to upgrade my house from 100 amp service to 200 amp service just to put a car charger in because I didn't have enough draw. If every house does that, in my neighborhood, it's from the 60s and 70s. If every single house wants to put a car charger in, every single house is going to have to go from 100 amp to 200, like increase their amperage. Like when my dryer kicks in, my lights in my house go
yeah,
boom,
yeah,
right?
yeah,
Like it's old, right?
yeah.
And so we're only going to be increasing in every new house. But so the metric of how energy efficient a house is the wrong metric to use
Mm.
because we're adding things.
Yep,
That's it.
yep.
And I haven't done the heat pump yet, but now because I went to 200 amp service, now I can put a heat pump in. I can do all those extra things that I couldn't do before. So do we have to shift our sort of thought process into it? Because I feel for the politicians in a way because I think it's going to backfire on them because people are going to turn around and go, look, you did all of this and now we're consuming more energy. But you have to bring in all energy. So if we're all charging our cars at home, we're not going to the gas. Like my wife is like, someone asked her once, so what's the price of gas for you? She says, I don't know. I haven't tanked up in a year.
No.
And
Yeah,
people are like, well, what do you mean? I said, well, I have an electric car and I charge it at home. I work 10 minutes away. I charge it every 3 days. I don't ever buy gas.
beautiful. Well,
Our gas bill from our old car pays for a car payment for the electric car.
yeah, yeah.
Go
Well,
figure.
if the prices go up, that's what's going to kill the politicians. I can guarantee you of that. If it ends up
Yeah.
costing more, they're going to have to watch those hydrant prices. Listen, Anton, that's time. We should cut it off there. But I really want to thank you. That was a great talk. I think that people have a nice basis. We're going to put your contact information on the end here. So that if people have further questions and well, I'm sure they will, they can reach out to you. But I want to thank you again for joining Net Zero Building and giving us a great talk on high performance fenestration.
My pleasure. I like to talk about stuff. So thank you for the opportunity. So.
Take care.